Right. Now in this video lecture we would be going through functional groups and homologous series, right? Functional groups are really important, right? Because using functional group you would be able to tell what kind of organic molecule is this, right? So in short, if I want to define functional group determines the chemical properties of any organic molecule, right? All chemical properties or chemical reactions that organic molecule undergoes depends on its functional group, right? And what is homologous series? Homologous series is a group of organic compounds, right? It's a family of organic compound that have similar chemical properties and they have same functional group, right? And the members of homologous series are known as homologues, right? And each member differ from one another by CH2 group, right? I'll just show you that. So in short, what is a functional group? Functional group is that part, right, of organic molecule that undergoes chemical reaction, right? So the chemical properties of any organic molecule depends on the functional group, right? Functional group is part of organic molecule that take part in reaction, let's say in chemical reaction, right? And all chemical properties depend on, or chemical properties of an organic compound depend on functional group. Right. Now in short, if you want to define what is homologous series, homologous series is a group of similar organic compounds that have same chemical properties and they have same functional group, right? Homologous series are series, or we call it series or groups or families of organic compounds that have similar chemical properties and have same functional group, right? Important, same functional group. Right? And since I said it is a series of organic compounds, a family of organic compounds, in one homologous series there are number of organic compounds that have same functional group, right? And each member differ from other, right? That follows it, or the one which is before it, by CH2 group, right? We'll just see this, right? And each member of homologous series is known as homologue, right? And this phenomena is known as homology. This is what you will see in your books, right? Now let's see, for homologous series CH4 C2H6, right? This kind of series CH4 C2H6 C3H8, C4H10. Right? This is a kind of series. This will keep growing, right? And this series, each member, right, both two consecutive members of this series differ by, like I said, CH2 group, right? If you see these two differ by CH2 group, right? If you, what I mean by CH2, if you add CH2 here, right, if you add CH2 to first group, right, to first member of the group, to first homologue, what you will get is the second member, C2H6, right? Now if you add C2H2 to it, you will get the third member, right? This is what it means. So two members, consecutive members, differ from one another by CH2. If you see these two also differ by CH2, right? So these are homologous series, and in homologous series all have same general formula, right? All members have same general formula, right? For example, if instead of this I take say CH3COOH, right, C2H5 COOH, C3H7 COOH, C4H9 COOH, right? This COOH represents a functional group, right? And what is the general formula of this? This is a homologous series, right? Functional group is carboxylic group, right? So this homologous series is of carboxylic acids, right? So organic compounds that have carboxylic group are carboxylic acids. So this is a homologous series of carboxylic acids, right? And their general formula would be CnH2n plus 1 COOH, right? If instead of COOH I put OH, this will become homologous series of alcohols, right? And for general formula in that case will become CnH2n plus 1 OH, right? So this is your homologous series, right? And if you see any two members, difference between any two members, let's talk about these two. If I subtract this from this from this, what I will get? COH minus will cancel, COH will cancel, C2H5 minus CH3 will become CH2. So two consecutive members will differ by CH2, right, as the definition says, right? And all have similar chemical properties, right? All have similar chemical properties and have same functional group. All have COOH group, all have same functional group, right? And all have same general formula also. Right, now let's talk about functional group. Functional group is, we know that organic compounds are derived from hydrocarbons, right? What are hydrocarbons? These are hydrocarbons, right? Methane, ethane, propane, butane. Hydrocarbons are those organic compounds that contains only carbon and hydrogen, no other atom, right? If we talk about this is not a hydrocarbon, this is an organic compound in which one hydrogen atom of a hydrocarbon is replaced by a carboxylic group, COOH group, right? If I take CH4, if I replace one hydrogen atom, with COOH group, what I will get is CH3COOH, right? Similarly, if I take say methane and if I replace one hydrogen atom with one OH group, OH is your, we call it a alcohol group, what I will get is CH3OH, right? Similarly, if I take CH3, this time let's take some other, let's take another hydrocarbon, C2H6. C2H6. Replace one hydrogen with say CHO. CHO is a aldehyde group. What you will get is C2H5 CHO. Right? So, any organic compound, right, consists of two parts, right? This is your hydrocarbon part, right? Suppose this is your organic compound, right? This is your hydrocarbon part, and this is your functional group. Right? And if you want to expand it, it looks like this: C double bond OOH, carboxylic group. Right? You will learn about these, how these structures are in future chapters. Right? So, in general, if I want to make a general formula of this, it would be RG. G stands for functional group, and R is your hydrocarbon part, right? And like I said here in the definition of homologous series, chemical properties of any organic molecule depend on its functional group, that is the COOH, OH or CHO group, right? This group, these are functional group, this are functional groups, and it is on this functional group that the chemical properties of an organic compound depends, right? So, on functional group, or in general when we say G is a functional group, on this functional group, chemical properties depends, right? And it is this functional group that actually reacts when an organic molecule reacts, right? So this functional group reacts in chemical reaction, right? And so it is this functional group that takes part in chemical reaction that will decide the chemical properties of any organic compound, right? Right? So it is this functional group that will decide the chemical properties of any organic compound, right? So I hope this is clear. How to define a functional group? It is that part of organic molecule that will decide the chemical properties of any organic compound, right? And it is this functional group that takes part in chemical reaction, right? And what about the other group? Why, if this is your other group, why this does not take part in chemical reaction? This group. Why this group does not take part in chemical reaction? The reason is that CC bond, you may have a CC bond also here, right? Like if I talk about this compound, it is like this, right? So here you have CC bond and CH bonds, right? So these CC and CH bonds, right? These bonds are strong bonds, right? Their heat of dissociation is high. Whereas if we talk about this CO bond, right? This CO bond or C double bond or O bond, these bonds undergo attack by reagents, right? These are easily attacked by reagents, right? and since this contains a double bond which has a pi bond, we know a pi bond is a weak bond, so it get easily ruptured or it easily breaks in a chemical reaction. So functional group, the part of the organic molecule which is a functional group, is more reactive and decides the chemical properties, right? Whereas the other part, the hydrocarbon part, is less reactive because of high bond dissociation energy of carbon-carbon and carbon-hydrogen, right? So this part, this hydrocarbon part, will decide the physical properties of organic molecules, right? This defines the or decides the physical properties of organic molecules, right? And you will see that as this part keeps growing, right, like as we are coming down CH3, C2H5, C3H7, C4H10, this organic part is growing, right? So as this organic part will grow, the physical property will show regular gradation, that is they will slowly increase. Physical properties on this is the hydrocarbon part, right? And physical properties depends on this hydrocarbon part, like melting point, boiling point, right? All these are physical properties, right? So you will see there is regular gradation is melting point and boiling point, right? Solubility is again a physical property, refractive index, Ri, all these are physical properties, right? So just remember one important thing, that if you have an organic compound, its chemical reaction depends on what? On functional group, because functional group takes part in chemical reaction, right? And why it takes part in chemical reaction, why not the other part, other hydrocarbon part? It's because hydrocarbon part has CC and CH bonds, which are strong bonds, right? So they do not get easily ruptured, whereas the hydrocarbon part, it consists of bonds that can easily be ruptured or that can easily be attacked by reagents, right? For example, if you talk about OH, right? OH, it will easily lose H, right? And will undergo a change or a chemical reaction, right? So likewise other like CHO group, if you talk about, right, this gets easily attacked by electrophiles, right? Proton easily attacks this H, right? And this H can be easily, it can easily lose this H, right? So there are various things that decides the chemical reactivity of organic compounds due to functional group. So it is the functional group, right, that makes the organic molecule react, right? And the hydrocarbon part decides the physical properties, which are melting point, boiling point, solubility, refractive index, etc., right? So I hope this is clear, right? What is a homologous series? Homologous series consists of organic compounds, right? And all organic compounds in a homologous series belong to a common family, a common group, right? That have same functional group and have similar chemical properties, right? And each member differs from the other by CH2 group. So if you know first member of the homologous series, keep adding CH2, 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 you will be able to build the entire homologous series, right? And the homologous series have the same general formula like this, right? And these organic compounds are, like we said here, these organic compounds, all these are derivatives of hydrocarbons, because we are replacing one hydrogen atom, right, in each of this, and replacing hydrogen atom, you can see replacing hydrogen atom with a functional group, right? So what you get is an organic molecule, right? So I hope all this is clear. Thanks.